Lecture 4, application of the symbols. Dot product, cross product, and mixed product. Now, don't forget, any question, just, this is my personal contact, okay? kafthompson@gmail.com. And this is my link, okay? https carlosthompson phd.com.br, okay? And also, this is if you want some contribution to the channel, PIX 327-533-737-87. Lecture 4, Part 1, General Relativity, Definitions and Properties Related to the Cartesian Coordinates, Classical Mechanics and Electromagnetism. Now we are not going to talk about, in this lecture 4, we will not talk about the Cartesian coordinates. We'll talk about, in general, coordinates. Okay? I will not mention about coordinates. But let's see. Classical mechanics and electromagnetism. So all this discussion from lecture 1, 2, 3, and 4 is valid also for electromagnetism, okay, for students, undergraduate students, graduate students. You see, there are important concepts that in general they are not emphasized in the current literature about this subject. It's as follows: physical laws, postulate, definition. You see, you must assume no question when you have, for instance, the first law of thermodynamics, second Newton's law. There is no question. You must accept. Einstein postulate for special relativity, postulate. There is no discussion. You have to accept. That's very important. And also, the word called invariant. What means invariant? Okay? Scalar, vectors, point, do not depend on coordinate system. For you to understand clearly this, I like to give an example, this very interesting example that you learned in the high school. Okay? I'll show you here why invariant is important for you to understand what it really means. Okay. Suppose I have a table and I have a block over here. Okay, that's a table, that's a block. A block has a weight, P. In Newton, okay, that's a force. Okay, I isolate this block. Then I have the earth and this block P over here. Okay? And the table reacts. That's a force, the reaction force that acts on the block, that the table, it reacts as a normal force. This is normal force. Normal force. This is a gravity force. That's a weight. That's a weight. Now, let's choose a coordinate system. Okay? I'll choose a coordinate system like this one. X and Y. Okay. The summation of the force on the x-axis, see? Summation of the force is equal 0 because I'm sorry. This y is equal 0 because the projection of this normal to the x is 0 and projection of p on 0 is 0. Summation of f decomposes the xy. You see, I have here n, I have here p. The resultant r will be n minus p is equal 0. You see? So r summation of x plus summation of force y. This is equal 0. Because this is 0 and this is 0. Now look how interesting this. I will erase. Let's take a paper here. Now I will do as follows. Now will you understand what I'm talking about the word invariant. So, on the first case, I have x, I have y, and p and n. Okay? Now, I'll choose another coordinate system like this. Suppose x prime already here, and y prime, and this is an angle alpha. Okay. Now, look how interesting. I will work in the x prime, y prime axis. Okay. Now, what is the projection of n on x prime? This is my angle alpha, okay? Then I will have a positive, okay, and cosine of alpha, okay? I'm sorry, sine of alpha, because sine of alpha, because the opposite, okay, to the angle alpha. Now, P, you see, I project P over here, you see? Now, it's minus because this is the orange. So, minus P sine alpha, okay? This is projection of f on x prime. Now, I will now project on the y prime. See? So, the y prime summation of y prime. Then n projected, I will have a positive, okay, a positive. I have plus n cosine alpha, okay. Look, if I project here, I have my x here, see? This is y prime, y prime. If I project over here, this will be minus, because minus and plus, minus p cosine alpha. Now, you see, the resultant, this will be 0 and this will be 0, okay? Because n is equal p. Now, you see, the resultant r is equal summation of x prime plus summation of y prime is also 0, okay? The same here. So the resultant of the force that acts on the block does not depend on the reference, you see? That's why the resultant, this is invariant. Invariant. See? Another point that I would like to emphasize, you see, is this. Let's suppose we're still talking about invariant, okay? Now, suppose I have a temperature. Suppose another example, okay, for you to understand